I'm in the middle of taking a test. That's funny. So I only have 3 more questions to get through. And we have an hour and 22 minutes to get through 3 questions. So, but they're like kind of long questions, but still. Wendy's. So we're looking for Wendy's something or other. That was fine. So it should be this one. So we have chicken and hamburger. So it's probably the correct one. This Wendy's. That was funny. Hamburgers and chicken sandwiches. That was funny. Is this a wait, hold on. The demand for hamburgers is normally distributed. It's not, mean of 450. Hamburgers mean 450. Oh, for a second I thought I was wrong. Hamburger 450. Standard deviation of 80. And chicken sandwiches is normally with mean of 120 and the standard deviation of 30. Answer the following questions. Why are there 3 sheets? That's weird. Okay. So this is a pretty simple one. This is kind of similar to the other one. Oh, you know what? I think I might want to look up the answer to C, because we had a homework question that was similar to this, and I wasn't entirely sure how to answer C, but I was an idiot and didn't know that there was an answer key. I could have just looked at the answer. But anyways, first we'll do A and B. Those are simple. So A is going to be here. B is here. So A. Oh, come on! I clicked the wrong thing. I'm surprised there's only 2 questions. 2 calculations I have to do. That would be funny if I closed the wrong tab when I click the X button. But anyways, how many chicken sandwiches must the restaurant stock to be 99% sure of not running out? So 99. So is it the 99th percentile or the first percentile? So the number that, so running out 99.9. That's funny. Okay, chicken sandwiches. I have to. Man, why is it so hard to like figure out? Is it the 99th percentile or the first percentile? So the number such that 99% of results will be under it. That means it's the 99th percentile. It's going to be way above the mean. So yeah, it's the 99th percentile for chicken sandwiches. So 99th percentile for chicken sandwiches equals norm dot dist. So 99th percentile, not dist, it's int. So 0.99 chicken sandwiches mean is 120. And the standard deviation is 30. So 99% sure that you will not go above 189. Oh man. Oh man. That's way more than 120. But that is correct because it's a mean of 120, standard deviation 30. So how many chicken sandwiches must they stock to be 99% sure of not running out? So 190. We'll just say 190 is the answer. Really? Numlock? Come on, man. So Yeah, I calculated this and then I just raised it up to 190 because that's more. That's funny. How many hamburgers must a stock to be 99% sure of not running out? Same exact question, 99th percentile for hamburgers. Same exact question except for hamburgers. So equals norm dot inv 0.99, mean 450, and the standard deviation of 80. So they have to stock at least 637 hamburgers to not run out. Man, that's a lot. So wow, they have to stock a lot of food. 637. Now see, I'm now going to look up the answer. Now the question is, what question is it? So this is going to be from chapter 5, and so percentiles, normal distribution. So it should be at this exact type of question should be here. I'm trying to figure out which one so I can look at the answer. Yep, I'm literally looking up the answer to a test question. Well, not really, but. So it's number 25, it looks like, I think. If it's not one other. Okay, so probably number 26. So 526. Whoops, my email signed out. Whoops. Oh. I have to open another tab. Awesome. And how much time do I have left? 1 hour and 15 minutes. I'm doing just fine. I'm not even halfway through the time limit yet. So, like, I could type an answer that I think is the answer, but I'd rather be sure that I'm getting the right answer. So, and I'm pretty sure this is open book test. So, anyways, so 526 would be in this set of problem solutions right here. All right, it might not be realistic if hamburgers and chicken sandwiches are substitute products. Customer will order one if there is none of the other. Then the two demands would be negatively correlated. Still, it's not clear that this would have a large effect on the probability in part C. Weird. So the thing I was saying, and I'm not going to explain it because I'm under a time limit here. I'm not going to copy this answer. I'll write it at my own words. In fact, I could write it. I could just copy my answer for what I wrote on my homework assignment. I'm not copying it word for word, otherwise it'd be like cheating. I'm not going to look up my answer. I'm just going to write another answer. So, insert text box. So, what's the question again? Why might the assumption of probabilistic independence not be valid? I'll probably just write a short and sweet answer and say that. Because it is possible that I don't want to say they're substitute products because that's a copying of the answer. I think I accidentally copied what the other one said. So, okay, we're done with 3 out of 5, I think, right? That'd be funny if I messed up somehow. Pretty sure I did this right. It's 99th percentile. This was much simpler than the homework problem I had to do. Wow. Right. So let's close this. Get out of here. And this one, save, close. We only have 2 more left. Wow. And we have a whole hour and 9 minutes left to do 2 questions. Oh, man. Man, I'm having a much easier time on this test than the last test. Probably because I actually studied for like 40 minutes. Literally only 40 minutes. But yep, that 40 minutes made a difference. And also, I realized I'm having a much easier time with this test because I actually am taking advantage of my resources much better than before, because I'm taking advantage of the fact that I have all my previous quizzes open. Well, I haven't used them at all, but I'm taking advantage of the fact that I can look at the answers for other homework assignments. And I actually, before I even started the test, I made a mental note of which. Okay, shut up. I'm just going to keep going here. Okay. Oh no, this one. Wait just a sec. No, it's not this one, because this is binomial. So this is not the right one. It's not this one. Close. It's actually this one, you would think. Binomial distributions. Fun. Fun time, everybody. That was one. Binomial random variable number 5, probability 0.4. So I'm just going to make sure they match. Prime probability x is less than or equal to 3. Find the probability that x is more than or equal to 3. Find the mean or expected value of x. And calculate the variance of x and the standard deviation of x. Whoa, wait. I'm an idiot. Oh my gosh, I just realized. Okay, so technically, there are actually 1, 2, 3, 4, 5 questions left. Dang it. Yeah, it's fine. I'll be fine. I'll be fine. So that matches the question. I'm going to have to look up how to do the mean and standard deviation because I can't remember how to do that. That's funny. That's just funny. Okay, so probability x is less than or equal to 3. So to do that, you do equals find home dot dist. So 3 trials 5 Hold on a second. I'm confused. That's all you need to know is the number of trials and the probability? Probability of what? Probability of what? Wait, I'm such a moron. It's a probability of success. I'm an idiot. Okay. Dang it. Binomial dot dist. So there's 5 trials. The probability of a success is 0.4. So what's the probability that you're going to have less than or equal to 3 successes? That's what this means. 5 probability is 0.4 and less than or equal to, so you're going true. So probability that you'll get less than or equal to 3 is 91%. Okay. Probability of more than or equal to 3. So you're going to do equals 1 minus. Well, what's the opposite of more than or equal to 3? Less than 3. But this will give you 2 or less, 3 or less. So you want to actually do 2 or less. So 1 minus probability of getting 2 or less, right? Good. Hope I'm doing this right. I feel like I might be messing up. I'm going to look at binomial. I'm going to double check this. I have plenty of time to. That was funny. I have plenty of time to check this stuff, so I'm going to check. So probability of less than 70. Oh, wait. No. No more than 65, yeah. So this gives you 69 or less. This gives you 69 or less, so I was correct in the way I was doing it. Okay. So 1, yeah, and if you want more than or equal to a number, more than or equal to, okay, so this is more than 65, but what if you want more? At least 59, so 59 or more. If you want 59 or more, you would have to do 1 less than that to get it. So, or it's 1 minus 1 less than that. So, so 1 minus binomial dot dist, great, equals 1 minus. The opposite of more than or equal to 3 is less than 3, so you want 2 or less, so 2 out of 5. Probability of 0.4, true. Probability that you're going to get more than or equal to 3. $31 something. And then okay, so this is the one where I'm not entirely sure. But I have the textbook, so I can just look right there. I'm already at the section. We want the mean. How do you find the mean here? So the mean is equal to n times p. That's so easy. What? Wow. E to the x, or e of x, is equal to n times p. Well, that's simple. Okay. Equals this n times p. Like, I'm making it so complicated, but it's literally just do this times this. It's just basic multiplication. So simple. The mean is going to be 2. That makes sense. And the standard deviation is the square root of np times 1 minus p. Well, now that's going to be fun to type. All right. Well, I'm gonna just copy this so it's easier. It pasted the wrong thing. Oh, that's funny. Now you know what I was copying and pasting earlier today. That didn't work. Oh, man. I can't copy and paste it, unfortunately. So we'll just have to switch back and forth on, which is very annoying. So first of all, we want square root equals squirt. That's funny. So parenthesis. Now, what do we want inside the square root? Well, we want n times p. So we have this times this times parentheses 1 minus p this parenthesis because it's a square root. So we have square root of n times p times 1 minus p. The square root, we have the square root of n times p times 1 minus p. That has to be right. N times p, square root, n times p times 1 minus p. That is the standard deviation. And 1.09. So, there you go. And then problem 20 is Poisson. Okay. So I think we're good for problem number 19. Apparently, there's more problems than I thought, but anyways, we're fine. We still have so much time left. We have, how much time we're going to put? We'll put this over here. What are you doing? Put it right here, please. I don't know what I was doing there. Okay, so we have completed number 19. That's funny. Now, unfortunately, it tells me I need to calculate the variance of x. Oh, fun. Well, fun. The variance is going to be the standard deviation squared, right? Because the standard deviation is just the square root of the variance. That's funny. It says calculate variance. I'm going to follow the directions. Var x. I'm going to follow directions. The variance is always the standard deviation squared equals this to the power of 2. So there you go. Wow, it's exactly 1.2. Because it's literally just this inside part without the square root thing. So, but anyways, so now we're done with number 19, right? Let's see if there's anything else I'm missing. That's it for number 19. On to number 20. The number of arrivals at a local gas station between 3 and 5 has a Poisson distribution with a mean of 12. Poisson mean of 12. So I'm going to have to remember some things for Poisson. 12. The mean is equal to 12. But that does not equal lambda. Lambda is not equal to the mean. I have to look and see what is the lambda. I'm going to look it up in the textbook because I forgot. That's the great thing about open book. If you forget, you can just look in the book. If it is in fact open book, which I'm still nervous that it's not. Stop. Okay. Like, I literally didn't memorize what lambda is for Poisson. I just knew that I was going to look in the book when I got to that type of question. It's so funny. So it turns out lambda is the mean. Wait, what? It is the mean. I was wrong. Okay, fine. It says that lambda is the mean and the variance. So lambda is the mean of the Poisson distribution. I'm reading that correctly. So lambda equals, whoops, I went down too far. Lambda equals 12. Like, seriously, it's just the mean. It's just the mean. Like, I'm double checking, being very safe. It says that lambda is the mean and variance. They gave you the mean. Lambda is the mean. The variance is lambda, and the standard deviation is the square root of it. That was fine. Now, you do need the standard deviation to solve the question, right? Because when you do a Poisson distribution, you need a standard deviation, I believe, right? Probability that x is more than or equal to 10. So it's the same idea as the binomial. So if you want, maybe you don't. No, maybe you don't need the standard deviation to do the Poisson distribution. So if you want greater than 3, if you want, what's the probability of getting greater than 3? What's the opposite of greater than 3? Less than or equal to 3. And less than or equal to 3 is Poisson dist 3, 5 is lambda and true. So there you go. Very simple. So we're looking for probability of more than or equal to 10. Right? At least 10 is more than or equal to 10. And so what's the opposite of more than or? So I like doing the intuitive logic to solve this question. So what we're doing 1 minus the opposite of this. So what is the opposite of more than or equal to 10? Less than 10. However, this gives you less than or equal to a number. So therefore, you must go 1 less than the number. So 9, comma, the mean is 12. The mean is, I'm like going so safely here. Just so incredibly slowly and safe, just to make sure I get the right answers. But yeah, mean of 12 and true. So the probability that x is more than or equal to 12. 10. Sorry, 10. It should be more than 50%, right? Because the mean is 12. There you go. That was literally all of problem 20. That was it. My goodness. Because they gave you the mean of 12. The lambda is just the mean. So we're fine. Yeah, so we're done with 20. We have 21, and then we have 22 and 23, apparently. I feel like I'm taking too long because now I only have 50 minutes left, although 50 minutes is still a lot. The time it takes a technician to fix a computer problem is exponentially distributed. No, exponential. Did we even have any homework questions on that? I think we did. Most likely value is x equal to 0. Okay, the mean and the standard deviation are the reciprocal of lambda. Okay. The mean and standard deviation are the reciprocal of lambda. That is very important. So the mean is 15 minutes. So what is lambda? The value of lambda, according to this, the mean, okay, the lambda is the reciprocal of the mean, and the mean is the reciprocal of lambda, obviously. So the mean is the reciprocal of lambda. The mean is the reciprocal of lambda, right? And a reciprocal, the reciprocal of 10 is 1 over 10. So I'm being so careful. This is ridiculous. Lambda is equal to the reciprocal of 15 over 1, which is 1 over 15. So that's lambda. Lambda is that. Now, what is the probability that it will take the technician less than 10 minutes to fix the problem? Just going to double check this. Just double checking everything. Yes, all you need is lambda to solve it. So if you want probability of being less than a number is that. So there you go. Very easy. Probability that you get less than 10 minutes. So you have, crap, it's expon. Expon.dist. So equals x, so less than 10, expon.dist. X less than 10, lambda is going to be this, and true. So less than 10, it should be a pretty low probability. 0.48. Are you sure about that one? Feels wrong. They said that the greatest probability is 0. How does that make any sense? I'm like questioning myself everywhere I go here. That value for lambda feels weird. But it is correct, probably. Right? Lambda is the reciprocal of the mean. Why did they give you a lambda of 5 for this example? Is this really necessary? Lambda equals 5. Okay, I need to stop wasting time. We're done. We're done with this question. So we're completely done with this sheet, and don't do that. We're on to the last sheet, last Excel sheet, which is sampling stuff. Sampling. This is a very easy question, I'm pretty sure. Please tell me I'm opening the right one. Yes. Okay, so compute the point estimate of the population mean from the sample. N equals 20, calculate the standard error. Oh my gosh, it differs. Are you serious? What is the sampling error? Oh, I read A. I read B instead. Compute the point estimate of the population mean from the sample above. Calculate the sampling error in the problem. Assume that the population consists of the given 200. I'm just making sure they're all the same so I don't have to look at this one again. Because sometimes they differ. That's why I have to double check every time. It's very annoying. Compute the point estimate of the population standard deviation, standard error. Should you use the finite population correction? Explain why or why not. If yes, calculate standard error of the mean with FPC. If yes, calculate the standard error. Okay, so we'll see about that. Okay, so it looks like they're the same, so I don't have to go back. I can just look at this for the rest of the time. That was funny. So we literally have 43 minutes to do this question. I should be fine. Oh man, I'm running out of time though. I mean, if I run out of time, no, shut up. Okay, compute the point estimate. So all you have to do to get the mean is just equals average of this. Average of those. That looks weird. Don't know why it looks like that, but okay. And is it close? It's relatively close to the 0.881. So we're fine. So calculate that. What's the sampling error? It's equal to this minus 0.881. So it's point blah, blah, blah. Okay, so that's pretty simple. We're done with that one. Compute the point estimate of the population standard deviation. So all you have to do is calculate standard deviation. That's very, very simple. Equals standard deviation point S, because it's the sample and all these. So the standard deviation, and we're getting a 0.3562. 0.3562 seems reasonable. Calculate the standard error. Now the standard error is fun. I don't remember how to do that. Did I even save how to do that? I don't think so. Do I have it open in here? Oh, I do. Well, I'm close to it. I'm not quite there. Are you going to show me the formula for the standard error? Where is it? Oh, here it is. So here's approximate standard error. That's the one we're looking for. Because they didn't give us this population standard deviation. So it's going to be equal to the sample standard deviation so this divided by the square root of n. And what is n? N, lowercase n, is 20. So you just do that divided by the square root of 20. That's it. That's very simple. So like, just to be sure, it's going to be like 0.3 divided by like 4 point something. So it's going to be like, it's going to be less than 0.1, I think, right? Yep. So there you go. That's the standard error. We're this close to being done with this test. Wow. Just one little question left. Do we need to use the finite population correction? So I believe that you do n divided by capital N and then see, is that more than 0.05? And yet, if yes, then you use the finite population correction. Just going to double check. They say that if it's 5% or less, you do not need to use it. So you just do n divided by n, and then and yep. So first we will do n divided by n. So the n, so it's going to be equal to 20 divided by and 200, right? $200 is the capital N. This is going to be more than 5%. This is going to be 10%. No, we have to use the finite population correction. Great. Okay. So if yes, what is the value of FPC? So FPC The FPC is going to be a fun equation. Ah, jeez. Oh, man. Okay, so we're going to get square root. That was a funny noise. Anyways, how much time do we have left? 36 minutes. I think we're doing fine. We're on the last question, so we should be fine. The finite population correction factor is the square root of capital N minus lowercase n. So equals square root, and then we're going to have something divided by something, so we need another parenthesis. So it's the top part of the fraction is capital N minus lowercase n. So we have capital N is 200, lowercase n is 20. And then we're going to go divided by another thing. We have capital N minus 1. 200 minus 1. So we have square root of capital N minus lowercase n divided by capital N minus 1. So what we should get, I'm going to just estimate what we're getting. This is so safe. So it's like 180 divided by 199. So that's like, what, 90 something percent, and the square root of 90 something is it's gonna be like 9 point whatever. It's gonna be percent. That's awesome. That seems reasonable because when they were showing this graph here, finite, see, we have percent sampled of 10, we got 0.95. Oh, why did we get a different number? You gotta be kidding me, dude. We got 10%. They got a different number for FPC. How is that even possible? I should have gotten the same number that they got. Hello? Square root 200 minus 20 over 200 minus 1. What am I missing? How am I doing this wrong? 10% is sampled. Is it just different because of different numbers? It shouldn't matter. That shouldn't matter. You know what I'm going to do, just to be, I have plenty of time. I have 33 minutes. I'm going to double check their thing on the calculator here. They have 10 out of 100. That's 10%. That's exactly the exact same percentage that I have. So I should be getting the same number. I don't get why I'm not getting the same number. Okay. How do you do square root? I feel like I'm running out of time. Come on. Okay, second square root, and then alpha y1, and then we have 100 minus 10 divided by 100 minus 1. So I got their answer. Now I'm going to type mine. Square root. So 200 minus 20. So it is correct. My answer is correct. It's not, just because you have the same percentage doesn't mean you're going to get the same FPC. Okay, that's funny. So anyways, I got the FVC of 0.9511. So the standard error is actually going to be your original standard error that you got times your finite correction, or finite population correction. If yes, standard error. So the answer will be, you know what, I'm just going to move these over so it looks nicer. That didn't change anything. Oh man, I don't know why. I don't care. I'm just going to leave it as is. So this is going to equal this times this. So it barely changed, but it did change. All right, so we're going to write a text answer. We still have 29 minutes, and this is not our last question. Oh no. What? Wait, how is this not our last question? Okay, I better hurry up then. Wait, I just want to go and see what the next question is. Extra credit? I might do the extra credit because I have time. All right, I'm going to hurry up so I can do the extra credit. Dude, I might get over 100% on this test. That would be insane. Use the FPC because wait, hold on a second. Okay, so we're done with the last question of the test, and then there's an extra credit question. And so we're done with that. Close. And do I have time to do this extra credit? Dude, if I get the extra credit wrong, will I get points off? No, I don't think that's how it works. Usually for extra credit, even if you try it and get it wrong, it doesn't negatively affect your grade. So anyways, so we have a normal distribution. It's a mean of 40,000, the standard deviation of 10,000. Oh, dang. This might be harder than I'm thinking. We have weekly calculations? Weekly calculations, what does that have anything to do with the problem? Oh, maybe I'll skip this. I thought it was going to be easy. Well, why would extra credit be easy? Extra credit is usually hard. Oh, I hope I didn't mess this up. Okay. Okay, they gave you the weekly distribution, and then they gave you some yearly amounts. How do you do that? I don't know how you reconcile those two things. I'm not sure. How do you reconcile weekly with yearly? I'm not sure how to do that question, so I'm just going to skip it. And it's extra credit, so we're fine. I still might get 100%. That's how easy I found this test. But it's probably just because I looked up a lot of the answer, or a lot of how to do all this stuff. But anyways. So, I have 25 minutes. But is the professor going to look at the Excel sheets? Anyways. So basically I'm going to turn in the Excel sheets separately. Maybe I should label them. According to what question they're answering. I have time to do that, so I will. So that was question number 22. So this is question number 22. Binomial distributions 19, 20, and 21. And then this one was probably number 18. Wendy's. So that was number 18. And then this one was number 17, right? So this is number 17. And then this one's number 16. So number 16. Of course. So, that was pretty. I'm losing my voice. Okay, we're done. We just have to submit all those files. So, and man, I'm losing my voice. I just want to see if I got anything wrong before I turn in the stuff. It says I have 26 points, but that's because a lot of the test is the Excel sheets. It won't let me look at it. Maybe it'll let me look at it later, but anyways. Wow, that was so much easier than the last exam. What the heck? Well, this is going to be tedious, but I'm going to double check all these just to be sure I turned in the right thing. Man. So, we have finished the exam. If only I could see if I got anything wrong. Was every question worth 2 points? No, I don't think so. Crap, I wish I could go back and see if I got anything wrong. Because I can't tell just based on this. Oh well. So the reason that was so easy, well, first of all, I studied a little bit before the test, and second of all, I don't know. I basically used more resources to complete the test than I did before, or something. I don't know. Anyway.